Yeah, hello. I'm Ulf Hermann. I've been working on QML and various QML tooling for the last 6 years. It's nice that you're all here. And, you know, I know what you've been up to with QML too. I've seen code. I've seen what you've been doing, and I can tell you something. You've all been very naughty. And I got some presents for you. So to put this a bit in perspective, in QML2, we have the QML runtime, which consists of a QML compiler and a bytecode interpreter with the JIT, but we'll leave that out for now. And our bytecode interpreter allows us to do some nice things like debugging, QML previewing, dynamically compiling types at runtime via, for example, a loader element or eval in JavaScript. Nice things. And we want to get rid of that. So in QML3, we'll offer you a new mode of running QML. We'll compile your QML to C++. You won't need a runtime or a compiler at runtime anymore. Instead, we'll offer a C++ API with a new property system that Lars talked about just before, and a new metatype system. And your code will be faster. It will be easier for the tooling to recognize what you're doing. You'll get better code completion in Qt Creator and better compile time or even error messages from the tooling. And you'll be happy. And in order to get there, we need to change some of your code. Because our new QML3 compiler won't understand all the naughty things you've been doing by now. But fear not. We won't throw away the QML2 in Qt 6. You will still be able to run QML2 with dynamic runtime and a compiler attached to that. You will be able to do QML previewing and QML debugging. You just won't get the new features of QML3 for that. And the QML3 compiler will also be able to generate bytecode, so you will be able to debug or preview your QML3, albeit slower, but that will still be possible. And QML3 will actually be a subset of QML2, so you can start adapting already now. So how do we get there? We'll start adopting best practices right now. We get already in QML2 better scalability. I'll talk about what I mean with that in a minute. And once we get to QML3, you'll have an easier time to migrate and gain with that better tooling, better performance. So what is scalability? Your code will be more readable. By just looking at your QML document, you will know what each property means or each reference means. There won't be any magic properties injected from the context anymore, for example, or the same name being in multiple objects, and you don't know which one refers to that name refers to, actually. And you will gain flexibility. So you will be able to reuse components in different contexts. You will be able to fearlessly update your dependencies without worrying about additional properties showing up in unexpected places. And you will be able to explicitly declare and manage your dependencies, which is different from the situation now, where you change something about your dependencies, and then something breaks, and you say, so what are those best practices I'm talking about? those can be divided into two groups. Some of them are available right now. We've already implemented them. They will be usable in Qt 5.14 or Qt 5.15. And some of them are still kind of vaporware. We are currently building those. So what you can already do right now, and what we can help you with already right now, is avoiding unqualified lookup in the root scope of a component, and avoiding context properties, and using required properties, mostly as a replacement for context properties, but also in other places. And you can register your types declaratively rather than calling QML register type somewhere in your library that the tooling will never find. And where we're getting with 5.15 is we will avoid group properties. We will use inline components instead to recreate the whole object. We will get rid of minor versions. We will introduce private properties. And we will find a definition for a stripped-down language that doesn't require a garbage collector, that you can use as a small subset of JavaScript, which will also be compatible with QML 3. So let's start. Unqualified lookup in the root scope. So you have here this toggle button. It's a rectangle. It has a color. If it's active, it's green. If it's not active, it's gray. It has this property active for that. And in that, there's a mouse area. If you click it, it changes. What is wrong with this? Anyone wager a guess? I see someone there. Yes. Yes, this is an unqualified lookup. The active, that's labeled in red there, accesses directly the property of the parent object. And so what the QML engine does is, oh, I don't know this thing, so let's go through all the root scopes of components to see if there's an active somewhere. Oh, I didn't find that. Let's go through all the root contexts, all the context hierarchy that's valid for the current execution, and see if there's a active somewhere. And that can turn up all kinds of things. And incidentally, in this case, there's a property active directly in the first root context of the first document. And so this search terminates pretty quickly. But now, if you were to update your version of Qt Quick and your mouse area gained a property active in some future version of Qt Quick, which is not that far-fetched, then this code would do something entirely different. And you would never know. So to reiterate that, yeah, this active refers to the property active in the root scope of the component. A new version of mouse area might add that property. Then the button fails to toggle. So what do we do about this right now? Yeah, we invented this thing called versioning. So in order to avoid that new active property or mouse area from showing up in your code, you put a minor version on your import, which says import qtquick 2.0 right now. And that fixes things. Unless you actually want to use some new features of Qt Quick, then you're out of luck. Is that decent? Well, but how do we fix it? It's actually pretty easy. You just put an ID on your root object, and you use that ID, and you don't have an unqualified lookup anymore. You can increment the version however you like, and nothing will happen to that piece of code. So, unqualified lookup can be detected with QML-lint from Qt 5.14. QML-lint still has some flaws in 5.14, but in general, this is possible. It will be deprecated in Qt 5.15, if I'm quick enough. And it won't be possible anymore in QML 3. Now, next thing we'll talk about is context properties. Those are actually related to unqualified lookup in the root scope. Now, what do we have here? We have some text that says something advanced at, apparently a date, and we add that date to the root context. You see that red line there? It basically adds this to the root context of your view, which is the root context of the QML engine. And when you do that lookup for advanced there, it goes through all the context hierarchy and eventually it finds that thing. Now, what is wrong with that? Anyone? Yeah? It is slow, yeah. And it has the same problem as before. It is slow because it first checks all the scopes and the contexts are checked last, and then it has to go through all the contexts in order to find that one. Yes. It's only slow for on the first lookup, though, because we cache that kind of stuff. But how about that? Now, we instantiate that thing in a different context. And we say, oh, yeah, I also want to advance there. Oops. Yeah, there's no advance there. So this just throws you a runtime error. Or what about this? Our text item has actually gained a property called advance in Qt 2.10. And so this does something really funny. And so let's try to structure this a bit better. So what's the problem? Well, we want those context properties somehow in there, but they're not declared in the QML document. And so we don't see what kind of context the QML document requires in order to function properly. And then context properties can also be shadowed by object properties, not only of the object itself, but also of the root object of the component. And on top of that, of any root object outside of the component that, let's talk about that later. So how do we avoid it? Well, we invented that thing called versioning. I think we've seen that before. And on top of that, you can never reuse any components outside their original scope because they might require some context properties, right? Is that decent? Yeah, well, beauty is in the eye of the beholder. What can we do about that? We can declare properties on specific objects, and then they're declared, and you can see them, and you can set them from C++. There's QObjectSetProperty API. It will just do what you think it does. And for things that you really want to be singletons, you can use QML register singleton type. And we've given you a new function in 5.14, I think, or was it 5.15? I have to look that up. That registers an instance as a singleton. So you don't even have to pass in a factory function anymore. However, you shouldn't do that, but we'll talk about that in some slides further down. So if you want to use object properties to replace your context properties, it's fairly straightforward. Yeah, you just pick out the root object, set a property on that. Fine. Now you can increment your Qt version and you don't have to dread any instantiation of that thing in a different context anymore. If you want to use a singleton instance, you can do it like this. You can just register your singleton instance on a well-behaved URI, pass in the instance, mind that it will be shared between all QML engines. So yeah, you might be aware of some race conditions or similar things like that. And then you can explicitly import your singleton via the URI that you've given. And now the lookup is qualified. Nothing can happen to that. Or you register a singleton type. That's the old way of doing that. The factory function will be called for each QML engine, so there will be a separate instance for each engine. You won't run into funny interaction between different engines anymore, but you have to provide the factory function. Otherwise, it's the same. So, context properties are flagged as unqualified lookup by QML-lint, same as regular unqualified lookup, actually. They will also be deprecated in Qt5.15, and you won't be able to do that in QML3 anymore. Now, let's talk about models and delegates. What does this do? You have a view. You pass in a list model with an element that has a label. And you have a repeater. No, that's wrong. Yeah, the model should be, the delegate should be on the view, of course, not on the repeater. No, actually, it's right. Yeah, it is on the repeater. So this thing instantiates one item of text, and that receives the label. However, nothing really declares that your delegate actually needs a property called label. So you might instantiate this view with some other model, like just 12. And you will never know that this doesn't work until you try. Or you might actually add a property to your view that is something else than what you're expecting there. And label is such an innocuous thing that you might accidentally do that. And then you get interesting things in your delegate. So what's the problem here? Yeah, delegate needs some kind of access to model data. We don't know the exact type of the model data when declaring the delegate. That's kind of the point of the separation between models and delegates. What do? Well, implicitly, our views take the data from the model and pass it to the delegates as context. And yeah, the delegates just access random things, and that access goes to the regular context, to root object, hierarchy of lookups, and they find something. Is that the intended model data, or is that something else? We don't know. Is that decent? But how can we fix it? Well, what about just declaring what kind of stuff your delegate actually expects from the model? It's not that hard. For that, we've invented a new keyword. It's called required. If you add a required property to one of those delegates, then when instantiating the delegate object, it will check that this property is actually given as parameter to the instantiation of the delegate explicitly, not from the context or anywhere, but explicitly. And our views react to that and they check, does my delegate component have any required properties? And if so, then we do the new style delegate population and populate the required properties directly instead of putting the model data in the context. And if not, we do it the old way. So then we can write, yeah, our text delegate wants a property label that is required. Now, if we just have some labels somewhere else and we don't pass it as model data, it will complain. And you can see why. And you can also use your required properties for other things. You don't have to do that just for models and delegates. You can just use them on any component, and you can say, well, if that component is instantiated, I really want that property to be set. So this would work, kind of. I mean, it would fail because in one instance the property is not set, but that's exactly what it should do. So maybe I was a bit fast. Any questions so far? Yeah?
Yeah, when you showed the example where you set a property from C++ on a QML object using set property API, were you being serious, or was that you should never do this? Because that is in our experience a recipe for disaster to do that kind of thing. And it's something that we actively advocate against doing in all our trainings.
Yeah, that's why it's right here. You should do that. But people do that. So basically, set context property will be like this method, set context property. This will be deprecated in 5.15.
The next slide. You had a version in blue, this one, yes.
Yeah, you can set properties on objects if you like.
Yes, I know you can, but in practice, this leads to horrible code and mixing up of your layers in your architecture. You do not want your C++ code to know about the structure of your QML, and that's exactly what you're doing here.
Yeah, well, it's a replacement for an even worse pattern, yeah. But of course, there are better ways to do that in most cases. You might have a proper component and instantiate that from QML directly. That's what I would do.
Accessing parent, the parent property on the root of an item, as in, like, for example, parent, anchor fill parent, for example, in the declaration of a button, in button QML, top-level item accessing parent. Do you consider that to be unqualified in this context?
No, that's qualified. You just cannot expect anything in particular from that parent. Yeah, that's kind of a corner case. Of course, you can just write parent.color and implicitly expect that thing to be a rectangle. Yeah, and that color could be anything because it could be some other item. Yeah, that's also not nice, but yeah, I haven't found a better solution for that yet.
On one of the previous slides, you showed declaring QML types declaratively. What do you mean by that?
I'll get to that.
Okay, thanks.
In the slide about the set property method on an object, that one, in your example, it was set to the root object. Is there a way, because with the previous context properties, they're available at the root context, so you can access them anywhere. So do we need to, how can we set a property on a child object, for example, if we were to do that?
You should not do that, as we've determined before.
I know.
If you really want to do that, you can, of course, get the property called children here, iterate them, and find the child you want to set, and so on. Okay. So yeah, required properties. And I give you a civilized way of writing delegates. Can potentially be checked at compile time, will be available in Qt 5.15. Well, we've already implemented them. Now, about the type registration. What you do right now is, typically, if you have a application that has some types to expose to QML, somewhere in your main CPP, you do QML register type, some URI, version, name. And you have about 20 of those typically. And then somewhere else, you instantiate an engine and create a component from a file and probably create an object from that. And that one then uses one of your registered types, for example. And then somehow, if you do that with Qt Creator, you will see that Qt Creator knows my type in your QML code. Magic. What Qt Creator actually does is it checks all the QML register type calls in the C++ part of your project and uses them in the QML code model to figure out which types you might be there. So say, yeah, you want to do the same thing with QML_lint. So you run QML_lint over your code that uses my type, and your QML register type CPP is somewhere in your main CPP. QML register type call is somewhere in your main CPP. What does QML_lint do? That's also, you have some dead code lying around somewhere in that code CPP file in your project. It never gets executed, but it registers some types. Oh, Qt Creator is happy about that. We'll find your byte type, but it won't be what you expect it to be. And also, well, you have some, you have some hierarchy of URIs, and you calculate them, and you have some nice code that tells you which URI for which type to use. And so your QML register type call looks like that. And Qt Creator will see, oh yeah, it's cool, but yeah, the URI is so great. So what's the problem? The QML register type calls are pretty much invisible to anything. It's pretty much impossible to verify the compatibility of C++ types with your QML code. We cannot really do any compile time analysis on that. It's very hard to write a language server. I've tried. What do we do about that? Yeah, right now we have this funny heuristics in Qt Creator that somehow work in many cases, and everybody else doesn't even try. Is that decent? Well, that's very naughty. How can we fix that? It's actually not so hard. We can just amend our C++ types with information about what QML types will result from those. So we just define a few more macros. You write in your headers. And we add a tool that generates your type registrations from that. And on the side, also your QML types files that Qt Creator or any tools can read. How does it look? The simplest case is you just put QML element into the header of your type. And then you add QML types to your config in your QMake file. And that will do all the magic for you. And the type will be globally available under an import name and an import version you've given it. And everybody's happy. How that works internally, I've added an option to mock that causes it to output the metatype information into an additional JSON file. And there's a tool called QML type registrar that reads those JSON files and generates QML types files and type registrations CPP files and compiles the CPP files into your application, and off we go. Yeah, there's still a big to-do. We have to do the same thing for CMake, but we'll get to that. So the declarative style of type registration is available for Qt 5.15, so far only for QMake. It gives you better readability and toolability, and will be required in QML 3. Then, what else do we have? Those are the things that we haven't implemented yet. We are pretty close to finalizing inline components. So you will be able to declare multiple components in the same QML file, not only with the component, but also with the keyword, which gives the component a name that you can refer to in other places. That's what I'm demonstrating here. So you can declare some property that has a type outer type dot inner type, and you can just instantiate that. And that's to replace group properties with a full specification of the inner objects. Then, as we've eliminated all things that actually necessitate minor versions now, or the unqualified lookups, we can actually make minor versions optional. You don't need minor versions anymore. And that gets rid of a lot of complexity, I can tell you, and a lot of bugs. And then, on top of that, we'll add private properties to give you better encapsulation. So, group properties, my favorite topic. Say you have this. You have an item that has an inner item, which is a rectangle, and that has a color. So you can instantiate that and set inner.radius, and then you have a rectangle with a color, blue, and a rounded corner with a radius of 10. Fine. Now, you change that a bit. Your item doesn't put the rectangle directly behind the colon there, but it creates the rectangle somewhere else and references it in the assignment to inner. Well, suddenly your group property doesn't work anymore because the evaluation of that inner is deferred, and randomly the group property is evaluated before that, and tough luck. Arguably, that is a bug, but bear with me for a minute. Now, say you have your blue rectangle directly attached to the inner property, and then your child replaces that rectangle with a red one, and then your grandchild sets a corner radius in that. This is fine. Now, what if your child replaces the rectangle only after the grandchild has set the inner radius? Well, funny things happen. The radius property the grandchild refers to is still the one of the blue rectangle because it binds to the identity of the original inner rectangle and not to the inner property of the parent. Well, arguably, that's also a bug, but bear with me for a minute. Now, this is also funny. you have a rectangle with another rectangle in it and an extra property called I. And the R property has a type rectangle. Now you can read that I property when instantiating something else. Fine. You can even set a group property of rectangle on it, like radius. Fine. But you cannot set the I property. You know what? Because you can only set declared properties when setting inner properties. Arguably, yeah, well, is that a bug? I don't know. It's funny. Now, on top of that, yeah, of course, you cannot do any group properties with JavaScript objects, although you can read properties of JavaScript objects, or with variants, or you, yeah, what? Yeah. Okay, maybe you see where I'm getting. Group properties are just so buggy that it's really not worth it to salvage them, in my eyes. So what you really want is, you want to customize an object while keeping some of the default properties. Like you only want to customize specific properties and keep everything else. How do we do that right now? Well, when we instantiate the outer object, we somehow poke into its internals and set some properties on the internals. This is not only immensely buggy, it also creates immensely complex code in the QML engine. It breaks encapsulation, because you can do that to arbitrary depth, actually, and you can access all inner properties of everything. Is that decent? Well, that is so naughty. How can we fix that? Well, instead of manipulating the inner properties of some objects that our parents have created, and then hoping that we find the right ones and that it all works, we can just say, well, yeah, if you want to manipulate this thing, then you have to create a new one. And we can say, yeah, if you're creating a new one for that, remember that when we are like creating the original parent object, and then leave the child out for now. And we can say, okay, the parent object might give you a hint here. I have this type there, and that's what you can instantiate there, and you get all the defaults then. And that will be an inline component. What would that look like? Yeah, the parent QML would define a type, inner type, via the component keyword, and that would have the color blue baked in. And then it would instantiate that as its inner property. The child would know, oh yeah, this thing is an inner type, and it would instantiate parent inner type and add the radius. And that is fine. And that can be extended to arbitrary depth by just adding more components that derive from parent components. So the child would have another inner type. That would be a parent inner type with an additional radius. And then you could like replace the color or whatever, and it would be safe. You wouldn't have like multiple objects flying around that are manipulated from different places. So group properties will be deprecated once all the replacements have been finalized, and will then be flagged by QML_lint, and they will be removed in QML3. Inline components are well on the way. I'm pretty confident that we'll get them in 5.15, and they should be used to replace group properties wherever possible. And yeah, maybe you see those two to-do items there. They look trivial, but they are probably not. We need some kind of handling for value types like font and anchors, probably the two most prominent use cases for group properties right now. And we need to find a way not to initialize the overridden properties in the first place. So if you go here, you don't want to initialize the inner type of parent at all. Like you want to go straight to this thing here. Right now, the QML engine doesn't do that. It would create both. And then about minor versions. So say you have this example again. You have a item that has a property advance in the root item of the component and uses that in a child item. And that works because in our QQuick text, we have the advanced property flagged with the revision 10. And as long as this import doesn't increase to 10, we are fine. Now, as we've seen before, this is actually not so fine at all. So, yeah, we derive from that, create our native text that just adds native rendering. Incidentally, that imports a different version of QQuick. Now, that advanced property is exposed not only to that thing, but also to that thing, because it instantiates that, and this version is totally disregarded, and that fails. Oh well. So what do we do about that? As we've seen, we qualify our lookups. We say parent in this case. And that's not naughty in this case because we know what the parent is here. And then whatever that does can add properties there, won't fail. But if you look closely, you'll see that the minor versions are actually irrelevant now. It doesn't really care what minor version that is. And so the plan is you can just leave them out. Yeah, so again, what's the problem? We add properties in new versions of modules. We want to keep the old code compatible with new versions of modules. We have unqualified lookup, and that unfortunately finds those new properties, and that's a problem, yeah. How do we avoid it right now? And well, our funny versioning system, we've had that before. We hide the property if the version doesn't match. Yeah, that makes a horrible mess. And is it decent? Nah. However, if you avoid unqualified lookup, you can just delete all minor versions. That looks much more decent, doesn't it? Yeah, so import without minor versions is planned for Q5.15. QML-lint will eventually flag imports with minor versions, and QML3 won't do minor versions at all. Now, private properties. What's the problem here? Well, currently you have no encapsulation for your QML components. Everything you put in a QML component is visible to any other QML component that can somehow get a handle on it. Yeah, that even holds for the internals of sub-objects. You can do that to an arbitrary depth. There's no encapsulation. So what do we do about this right now? Yeah, we have lots of interesting workarounds there, like naming schemes. Like lots of properties in QQuick controls start with underscores so that you won't find them. You can do interesting things with JavaScript closures. So you define a function and then define some inner variables in that function, and then another function that you define in there can access those, and you pass that function out, and only that function can access. Yeah, that's great in JavaScript. Yeah, or you can embrace the horror. Is that decent? The horror is very decent. How can we fix it? It's actually rather simple. We just add a private modifier to properties. And suddenly, we can prevent them from getting accessed from places where they shouldn't be accessed. Now, this is planned for Qt 5.15. Not there yet, but once it's there, please use it. And then we have some things on the further Qt 6 roadmap. Using all those things and using a simplified scripting language, we should be able to make complex JavaScript and the garbage collector optional. So that will be in the QML2 realm. In QML3, we'll have a simplified language that doesn't need a garbage collector and has few, if any, heap allocations. Uses reference counting to manage those. As Lars has detailed before, we're going to move most of the property system to Qt Core. We'll have them lazily evaluated. We'll avoid redundant evaluation of properties, and we'll add a C++ API. And then, to facilitate tooling, we'll have a QML compiler library with a public API, so that you can compile your QML3 code to C++, or your QML2 code to bytecode. That should enable us to improve tooling and to write the language server finally. So yeah, that was all very naughty indeed. And here's something I got for you. So it's 3 bug reports. If you track them, you'll see what I'm doing about all those open projects I've mentioned before. So, any further questions?
In one of the last slides with the private properties, will QML flag occurrences of accessing private properties because it could break code?
Well, the accessing private properties won't compile at all, so QML will fail to, yeah, it will flag that by failing to compile it.
Yeah, another question. The QML namespace, you had in your .profile, you had a namespace and a major version in one of your examples.
Yeah, wait.
So that seems to be there's only one namespace per project.
Yeah, that is a restriction we intentionally put in. You have to have one URI per project, so per library or per plugin or application. You can't have multiple of those. I mean, you can, but then you have to do a procedural type registration. Or you split up your project into multiple libraries. If you have so many QML types in different namespaces, you might want to do that anyway. Yes?
Hello. Yeah, you mentioned native rendering in one slide I saw. And would you consider making native text rendering the default in QML3?
Now, that has little to do with QML. That's Qt Quick.
Well.
Hello. So building on my trouble of this parent accessor from before, when you create a component in QML and then you use it as like make an instance of it, you can access all of the now public properties that are declared inside of that component, right? Like, as in, if you have a text item, which is what provided by Qt, you can obviously assign to properties that are declared in text from the outside.
Yeah.
Now, in our projects, we've had trouble where we see that variables that are used as internal things get overridden on the outside. And the private public thing sort of solves that a little bit because it means you can hide your internals. But sometimes you have got properties that you actually want to write to and you want them to be public, but you just don't want people to assign to them from the outside? Do you have any thoughts around that? As in, they could replace an internal public variable from the outside, which you don't want.
I'm not sure I understand that. Of course, you can still write to private properties from inside the same object.
But sometimes on the inside, there's a delicate binding that gives that value. And on the outside, you don't want that to be assigned to.
You don't want to assign to some other property that's bound to the private property.
So read-only on the outside, writable on the inside.
Readable on the outside, so read-only properties. Yeah, well, that is already possible. There's a read-only keyword.
Is it possible to give some C++ objects for the properties also the statement required? Because at the moment there is no restriction that I didn't initialize the properties.
I didn't hear the first part. What kind of object?
I will instantiate from QML some C++ objects. And so I have defined a Q property, but I would like to have also the requirement that I have to initialize it from the QML port.
Yeah, that's an interesting suggestion. Yeah, we could add that to the Q property statement. But yeah, it's hard to enforce because in C++ initialization works kind of different. You cannot, I mean, yeah, I would have to think about that. I mean, you cannot really enforce that if you're instantiating the thing from C++, right?
Yeah, but at the moment, all the C++ object I use from QML have some properties, and the object need the information. So I will avoid that everybody who is use this object in the QML port forgets some initialization.
Yeah. Yeah, well, I have to think about that.
Okay.
Maybe you write a suggestion in Jira.
Hi, with QML 3 and more of JavaScript becoming optional and more of the code being compiled to C++, will the story for supporting value types of non-queued C++ types be improved, such as std vector and std string and so forth?
Yeah, that's planned. But yeah, it's not quite trivial, but I want to do it, yeah.
So you mentioned in your one of the first slides about the C++ API for QML. Is this in the realm of potentially, if it's compiled to C++, could we maybe in the future have the ability to use QML-defined types from C++, or even a compiled QML type that we can inherit from C++? Is that something that's in the scope of QML 3?
It's possible that you can do that, but we haven't defined yet how the compiled QML will look like. So that's what it depends on, basically.
So if you're removing the minor version, right? Right now I have a file, a text QML, and I increase the version to say, okay, I need the advanced property that I know it was introduced in 2.10, right? Mm-hmm. So if I run it with Qt 5.9, it will fail because it's too old. How do we do that now?
So you use the versioning in order to fail on too old Qt versions.
Right.
Yeah, we can add that somewhere to the build system and say, well, this is only valid for Qt 6.1 or something. That should be a different mechanism than like putting it in each file that this requires this version of something.
Could you explain what improvements are going to be made for QML refactoring? Because at the moment you have to do a lot of find replace at text level to make it work.
Yeah,
and that's quite error prone.
Yeah, right now the tooling is just bad because QML is just inherently hard to tool because of all those dynamic lookups everywhere. For example, when you're refactoring and you're changing the name of a property in the root scope of some component, you basically don't know what other places you have to check for lookups of that property. It's impossible to know. And that situation will improve with QML3, so we will at least have the capability of writing better refactoring tools.
Last question.
So right now you can use QGadgets from C++, but if you want to use them in QML, you have to assign them, well, you can assign them to a property var. Will also be proper type support be added for QGadgets?
Yeah, that's what I was planning in order to enable the dropping of group properties. I want to be able to create QGadgets declaratively in QML.
Thank you very, very much, Ulf. That sums up our talk about QML and its future. Thank you very much.